On September 18, 1959, a small metal sphere, no larger than a beach ball and weighing just 22 kilograms, was hurled into Earth's orbit. Its name was Vanguard 3, and despite its modest size, it carried with it the power to transform our understanding of the skies above. While the world remembers the Soviet Union's Sputnik as the first artificial satellite, few people know how Vanguard 3 quietly rewrote the science of our atmosphere, our magnetic field, and even global communication. This is the story of the satellite that proved sometimes the smallest machines make the biggest discoveries. The late 1950s were an age of unprecedented tension. The Cold War wasn't only about armies and missiles, it was also about brains, science, and technology. When the Soviet Union shocked the world by launching Sputnik 1 in 1957, America suddenly found itself trailing in the space race. Politicians panicked, newspapers declared a missile gap, and the American public demanded a response. The U.S. government turned to its fledgling space program. While earlier satellites Vanguard 1 and 2 had stumbled with technical failures, Vanguard 3 was different. Engineers from the Glenn L. Martin Company, today known as aerospace giant Lockheed Martin, had learned from their mistakes. The mission was clear: not just to launch a satellite, but to demonstrate that the U.S. could compete and win on the frontier of space. At just half a meter in diameter, Vanguard 3 looked unimpressive compared to the rockets and capsules that would follow. But appearances were deceiving. Inside its aluminum shell were finely tuned scientific instruments designed to probe mysteries that had eluded scientists for decades. Its goals were ambitious: to measure ultraviolet radiation from the sun, to analyze the density of Earth's upper atmosphere, and most importantly, to investigate the ionosphere, the electrically charged layer of Earth's atmosphere that plays a vital role in bouncing radio signals around the globe. For the first time in history, humanity would have an eye in the sky capable of directly studying this invisible shield. The ionosphere is a strange and vital region, stretching from about 60 to 1,000 kilometers above the surface of Earth. Without it, global radio communication as we know it would be impossible. Shortwave signals that traveled across oceans relied on bouncing off this charged layer, yet in the 1950s, scientists knew frustratingly little about how it actually worked. Vanguard 3 changed that. As it circled Earth, its sensors collected continuous streams of data on charged particles, solar radiation, and atmospheric density. For the first time, researchers could map the ionosphere's structure and watch how it shifted with day and night, with solar storms, and with the seasons. The satellite also provided groundbreaking data on the Van Allen radiation belts, discovered only 2 years earlier. These belts of high-energy particles posed a hidden danger to spacecraft and astronauts. Without Vanguard 3's contributions, NASA's path toward sending humans into orbit would have been riskier and far less informed. Beyond science, Vanguard 3 was also a symbol of resilience. At the time, the U.S. was struggling to prove its space program could keep up with the Soviet Union. Every successful orbit of Vanguard 3 wasn't just data, it was a political victory, a reassurance to the American people, and a message to the world. America would not be left behind. And yet, Vanguard 3 wasn't about military power. It wasn't carrying weapons or propaganda. It was carrying knowledge. Its success reflected something deeper: the belief that progress, discovery, and the pursuit of science were worth racing for. More than 6 decades later, Vanguard 3 is still up there, silently circling Earth. It has long since stopped transmitting, but its body remains as a time capsule of the space age's first steps. The data it sent back paved the way for modern telecommunications satellites, weather prediction systems, and space missions that rely on understanding the radiation environment of near-Earth space. Every time you make an overseas phone call, every time GPS guides your way, you are benefiting from discoveries that trace their roots back to this tiny metal sphere from 1959. Looking back, it's easy to forget how revolutionary Vanguard 3 was. It was more than a ball of instruments, it was a messenger. A small object that whispered secrets of the ionosphere. And today, when we hear about billion-dollar satellites, moon missions, and the dream of colonizing Mars, it's important to remember where it all began. Before the giant rockets, before the space stations, before astronauts walked on the moon, there was Vanguard 3. A 22-kilogram satellite proving that even the smallest of machines can open a giant window into the universe.